Hi everyone, it's Mrs. Johnson and welcome to today's lesson. Today we are going to begin our Chapter 1, Lesson 1.1, and we're going to start by talking about evaluating expressions. So you were given this note handout or note packet in class either on Wednesday or Thursday, and what I would ask you to do is to get that packet in front of you, get a pencil in hand, and you are going to begin to fill out this vocabulary. So I have already written the definitions into the slide here. However, I might recommend that you pause the video and copy down each one of these definitions and then listen to the examples that I give you and kind of add those examples in as I go through the video lesson here. Another option would be to utilize your textbooks that were assigned to you, and you could actually look up the vocabulary in the textbook if you would rather do that, and then compare it to what is written here. I'm going to go over the vocabulary briefly, and then we're going to get into the real meaning of the lesson in talking about algebraic expressions and what they look like and how we can evaluate them. So one thing you're going to find in expressions is something called a variable. This is a letter that is used to represent one or more numbers. Most of the time we are going to use the letter X. Okay, so we might use X, we might use Y, we might use A, any letter that's used to represent one or more numbers. Now, what we're going to be looking at in this lesson are algebraic expressions, and what this means is we are going to have a collection of numbers, variables, and operations. For example, we could have something like 5x, or we could have something like y minus 2. Those would be two examples of algebraic expressions. You'll notice here in the box there's a little side note that says an algebraic expression is also called a variable expression. Now, the main point of our lesson here is to learn how to evaluate an expression. In this case, we will be substituting a number for the variable, performing the operation, and then simplifying if possible. One of the things that we're going to be working with here quite a bit are exponents and powers. So you'll notice each part of this exponent, base, and power are kind of defined. So a power is the actual expression that represents repeated multiplication of the same factor. And there's two parts that make up this power. There's a base number, which is the number or expression that is used as a factor in repeated multiplication. So something like the number 2, this would be considered our base. And then if it's raised to the 4th power, this is the number that represents the amount of times the base is used as a factor. So this piece is known as our exponent. Okay, so utilizing that information, we're going to go through these algebraic expressions and see what each one of these things means. So we have 7t. What this really means is 7 times t, which indicates that we are going to be multiplying 7 and the value of t together. Okay, x over 20. When you see this written as a fraction, this really means that x is being divided by 20. In the third example here, you have y minus 8. And at this point, I think that most of you know that means that we are going to be subtracting. So the operation is subtraction. We then have 12 plus, and you actually want to write the word here, so 12 plus a, which indicates that we are going to be using addition. So pretty obvious, pretty straightforward with this first page of notes. We're going to be talking about expressions, and we really need to understand the meaning of each one of these. So as you flip the page and you look at evaluating expressions, you'll notice over here on the side it says to evaluate an expression, substitute a number for the variable and perform the operations, then simplify. As we look at this first one, it says evaluate the expression when n equals 4. So that means we are going to substitute 4 anywhere we see the letter n. So in this case, 11 times n really means 11 times 4. Okay? Hopefully you know that that is 44. So what did we do to find that answer? Two things. We substituted 4 for the letter n, and then we multiplied those numbers together. Okay, now in letter B, you have 12 divided by n. Well, again, n is equal to 4, so we will substitute 4 for n, and then we will divide to get a final answer of 3. Same idea in letter C. We will substitute 4 again for n, and then we will subtract, and hopefully we know that 4 minus 3 equals 1. So these are some real simple examples in terms of evaluating an expression. We have a little checkpoint here, so if you want to pause the video and try these on your own, that would be great. Or you can watch me walk through these examples here and see if you can match my answers. So we are told y equals 8 in this case. So this would mean 7 times 8, which would give us an answer of 56. In number 2, I substitute 8 for y. 8 divided by 2 would equal 4. In number 3, I substitute 8 again. 10 minus 8 would equal 2. And in the final problem, if I substitute 8 for y, 8 plus 6 equals 14. So those are the basics of evaluating our expression. We're given a number, we plug it in for the variable, and then we simplify by performing the operation that is given. The other piece to this lesson has to do with exponents. And as we look at these, we want to get familiar with the proper wording and how we should actually say each one of these expressions. So our directions say write the power in words and as a product. So in this case, you see 12 as a base number and 1 as an exponent. What this really means is 12 to the first power. So if I'm going to write this as a product, it means I actually want to perform the operation. I have 1/12. Okay? In letter B, you have 2 and a 3 as your exponent. So this means 2 to the third power, or with the number 3, we can use a special word and say 2 cubed. What this really means is we are going to multiply the number 2 3 times. So if we write it out as a product, we would have 2 3 times. In letter C, you have a fraction. We have 1/4 to the second power. So that would be the first way we could write it, but we also have a special word if an exponent is there, is a 2. We could say 1/4 squared. What this means is we would multiply 1/4 2 times. In the last one, we have a 4, a to the 4th power. We don't have any fancy word for that, we just say 4th, And what this means is we would multiply whatever the value of A might equal 4 times. So as you flip the page, you'll notice we have an example here. We have a little checkpoint, and we want you to write the power in words and as a product. So just as we did on the front page, we'll have 7 to the 5th power. So as I am speaking it, that's what you want to write down. 7 to the 5th power. And what this means is we are going to multiply 7 5 times. So we need to write 5 sevens in the box to show that as a product. Now number 6, we have 1/3 to the 2nd power. You can write this in that form, or you can say 1/3 squared. You will probably hear me say 1/3 squared more often than I say 1/3 to the 2nd power. And what this means is we're going to multiply 1/3 2 times. For number 7, you have 1.4 to the 3rd power. You can write that down, or you can write 1.4 or 1 4/10, which is how you would read the decimal, cubed. And again, this means we're multiplying 1.4 3 times. So as a product, we write it 3 times. At the bottom here, we are evaluating the expression. So you have y to the 3rd when y equals 3. So what this means is we are going to plug in a 3 for y, and we are to write out the factors. So this means we're multiplying 3 times. Well, 3 times 3 is 9, and 9 times 3 is 27. So in this case, once we multiply those 3 numbers together, our final answer would be 27. For letter B, we are substituting 1.2 for A. So I plug in 1.2. I have 1.2 multiplied 5 times. And I would probably suggest using a calculator for this one. So if you type in 1.2 times 1.2 5 times, you will get a decimal answer of 2.48832. Our calculator is able to perform this operation. We have a caret button on the calculator that can help you with this. So I will show you that trick when we get back into the classroom next week. Real quick, numbers 8, 9, and 10. I will write the final answers so you can have a checkpoint here, and we'll talk about these a little bit more in our meeting on Friday. Number 8 is 9. Number 9 would be 1/32, and number 10 would be 64. If you have any questions on this, please feel free to reach out to me. Please make sure this is completed for class on Friday or Monday, depending on what day you are given the assignment. Thank you all, and we'll see you next time.